Even though Cisco gives us that structured 7-step model, in some cases we're going to be able to skip a step or two because we've got experience, we've got intuition, we've seen this before perhaps. I remember when I used to work at a local university, if a problem report came in that said something like, my print job is going really slow, I'd seen that problem before. The kind of switches we had, they had a lot of issues with duplex mismatches. They did a really lousy job of auto-detecting duplex, and that would be one of the first things I would check. And many times, yep, duplex mismatch, and I could just fix it and be done with it. We can shoot from the hip, as Cisco says, and just go with our gut instinct many times. And that's really something that's developed over time. The more troubleshooting you do, the greater ability you have to shoot from the hip, as it were. And when we're going through all this information and we're eliminating potential causes, we're going to be left eventually with the actual underlying issue. Check out the Sherlock Holmes quote on screen that's saying that, yeah, after you eliminate everything else that's not the truth, whatever's left must be the truth. It kind of reminds me of the story about Thomas Edison. I remember, and there's different variants on the story, but it goes something like this. After thousands of written experiments in an attempt to invent the electric light bulb, Thomas Edison was interviewed by a newspaper reporter. And he asked him, Mr. Edison, how does it feel to have failed thousands of times? And Mr. Edison says, I didn't fail thousands of times. I found thousands of ways that it didn't work. That's the attitude we as troubleshooters need to have. Troubleshooting can be a very emotional process, I know. But we need to understand that it's never a situation of we're never going to figure this out. No, we can just try again, eliminate things that's not the issue, and we're going to be left with what is the issue. And remember, we've always got a safety net there. If our SmartNet maintenance contract is up to date, we can always contact Cisco TAC, and they can give us some assistance. One approach to troubleshooting might involve, if we're not shooting from the hip, we might use the OSI reference model. And go from there. We could do a top-down approach, starting with the application layer and working our way down. We could do a bottom-up approach, starting with the physical layer and working our way up. Or we could kind of start in the middle. Cisco calls that the divide and conquer approach. And when we're doing our analysis of what we're finding, oftentimes it's useful to be able to compare the device's configuration that's having an issue with a configuration of a device that is working correctly. Or compare it against the baseline configuration, which hopefully is in our documentation. We're able to spot the differences, as it were. In fact, notice what's going on here on screen. We've got a couple of switches, or a couple of routers, R3 and R6. They should be configured identically for the most part, but notice this. I'm noticing a difference. The DNS server's IP address is slightly different on these two routers. That might be leading to an issue that our users are experiencing. Can you spot the difference? Another valuable thing we can do is follow the path. If I cannot get from my workstation to a device on my network or on the internet, can I get to my default gateway? Can I get to the next hop? Can I get to the next hop? We can follow the path, maybe using a traceroute command to see how far we do get. And wherever the communication breaks down, we might want to focus our troubleshooting efforts there. And sometimes we just want to swap out components. If things aren't working correctly, maybe it's a bad cable, maybe it's a bad switch, maybe it's a bad PC or a bad router. We hopefully are going to be able to swap out a component and say, all right, we swapped out the cable, the problem still exists. All right, let's put the cable back. That was probably not the issue. But in some cases, swapping out individual components can help us pinpoint exactly what's going on. Now here, we're going to take the top-down approach using the OSI model. Honestly, not a huge fan of this. I mean, it's sort of a gray area when you say that you're going to troubleshoot the application layer, because the application layer, what really lives there? It's not applications. I mean, your Microsoft Outlook email is not living at the application layer. What lives at the application layer are services, like email is a service. Unified Communications is a service, but it's sort of intangible. It's not that a specific application lives there, but in general, I see the approach. What we're doing here is saying, let's run an application on our workstation, like a web browser, or let's run Telnet, and let's see if it works. If it does not work, and I'm guessing it's not going to if we're troubleshooting a situation like this, then we can start to work our way down. But it's kind of difficult. How do you troubleshoot the presentation layer or the session layer? Generally, I don't find as much value in doing a top-down approach as we might with the bottom-up approach. With the bottom-up approach, we start down at the physical layer. And I find a lot of value in this oftentimes. And down at the physical layer, what happens when you call into tech support for your cable modem? They ask, is it plugged in? Yeah, that's a physical layer issue. Are we plugged into the wall? Do we have power? What about the condition of the cable? Sometimes those cables, those little RJ45 connectors, the plastic tab on the top, they can break off. And it looks like the RJ45 connector is securely seated within your network device, but it's really not. It's slid out ever so slightly just so that it doesn't make a good contact. We can check the cabling. Then we can move up to the data link layer. Are we learning, is a switch learning MAC addresses from attached PCs, things like that. We go up to the network layer. I think there's a lot of value in a bottom-up approach, but generally, in the real world, I'll do a divide and conquer approach. If I cannot get from my workstation to a destination I'm trying to reach, I'll try a series of pings using ICMP echo requests. I'll try to do a ping. Can I ping my default gateway? Can I ping the destination? Can I ping the router after my default gateway? You see, a ping kind of starts in the middle of the OSI model. It uses ICMP, which is technically a layer 3 protocol, and there's some argument about that in the industry. Some people say it's layer 4. It's got some layer 4 characteristics, but technically I would argue ICMP, it's a network layer protocol, and if it works, if our ping is successful, great news, we're good at layers 1 and 2 and 3, and then we can start looking in to the upper layers for the issue. Now, I mentioned using the traceroute tool. This is going to be very valuable if we're trying to follow the path. Following the path means, let's see how far we do get. Can I get to my default gateway? If I can I get to the next router? Can I get to the next router? And the traceroute utility, which, by the way, we can run on a router or we can run on a PC, the traceroute utility is going to give us a hop-by-hop analysis on our way to our destination. Maybe the destination is 5 router hops away, and maybe we only get through 3 of those router hops. Well, where does communication break down? It breaks down at router R3. Well, let's check communication between R2 and R3. Something might be going on there. It helps us isolate. It helps us focus our troubleshooting efforts a little bit more. Something else we said we needed to be able to do was to spot differences in configurations. If I've got 2 routers that should be running about the same, like these 2 branch routers we have here on screen, branch 1 and branch 2, they should have similar routing tables. Can you spot the difference? I'll give you a second to look and see. Can you spot a big difference? Yeah, this one's not too hard. Look at this. We've got a route learned via OSPF on the branch 1 router. We do not have a similar route. In fact, we haven't learned anything through a dynamic routing protocol on the branch 2 router. At that point, I would start to investigate my OSPF configuration. We also said that we could swap out components. Maybe I cannot get from my laptop A over to workstation D or E. Well, what might be happening? It could be something as simple as a physical layer issue. Maybe it's a cable. We could try a different cable. We could try a different switch port. Sometimes, as switches age, I've seen this happen plenty of times, individual switch ports will go bad. In general, the switch works. The lights come on, it powers up, but specific ports go bad. You might try a different switch port and then make plans to get rid of that switch, migrate to a fully working switch. But you might try different switch ports, different cables. If you do move a cable to another device, does it stop working? Does the problem follow the piece of equipment or the device that you're moving? If so, you may have just isolated the issue.